Okay, this is the notes on thunderstorms and how do thunderstorms develop. Thunderstorms are small area storms that form from the strong upward movement of hot, humid, unstable air. Under these conditions, when hot, humid air rises, it forms cumulonimbus clouds, the only type that can form thunderstorms. If the air is hot enough and humid enough, it rises really fast, making the air in the cloud highly unstable, and it can generate lightning. The notes on this are really simple. How do thunderstorms develop? Well, hot, humid air rises rapidly. So you've got hot, humid air coming up. As it moves up, it can't hold as much water because the pressure decreases, and that makes condensation start happening. How does lightning form? So what is lightning? Friction between the dust and ice particles within the cloud generates an electrical charge. Positively charged particles accumulate in the top of the cloud, and negatively charged particles build up at the bottom of the cloud. So how does lightning form? Friction causes charges to build up within the cloud. Now it's said that we have positive charges up here in the top of the cloud and negative charges in the bottom of the cloud. So at the top of the cloud here we end up with all these positive charges. Okay. And then negative charges accumulate at the bottom of the cloud. So the cloud ends up being kind of like a great big capacitor. Okay, back to the reading. When the difference in charge between the cloud and the ground is great enough, an electrical current flows between them and we see lightning. So in your notes, we have this negatively charged bottom of the cloud, and then we have the ground right here. And from the ground, we end up having charge moving up into the cloud, and from the cloud, we end up having charges move back down. The charges that are moving up in the cloud are positive charges from the ground, and then the charges moving down from the cloud are negative charges. And that's what we end up seeing as lightning. We are right here. Most lightning occurs within a cloud, but they sometimes strike the earth. If the positive charges build up on Earth's surface, a current can form from the earth to a cloud. Lightning, like all electricity, is very dangerous. During a lightning storm, it is obviously a bad idea to be outside. But if you find yourself out during a lightning storm, make sure you are not the tallest thing around. All electrical currents, including lightning, take the path of least resistance, meaning they go the most direct route from one charge to the opposite charge. If you are the tallest thing around during a lightning storm, you make yourself the shortest path. Avoid trees and other tall objects to stay safe.
What started as a routine stop for gas ended in a near-death experience for William Hall yesterday.
Started pumping the gas and I seen a very bright orange light followed by a very bright white light, and then total darkness. I went out.
Surveillance cameras at the K&K Food Mart captured this amazing video of a lightning bolt hitting the parking lot. A few minutes after Hall paid, you see the flash outside. Another camera caught Hall falling over after the bolt struck.
It was fortunate that it was not a direct strike. It struck the parking lot and traveled through Mr. Hall while he was at the gas pumps.
Hall was unconscious for about 5 minutes. He says he felt the current travel through him before he passed out.
Because I was very numb, shaky, hard to catch my breath. My heart was beating really rapid.
Apart from some small blisters on his elbow, Hall doesn't have any physical signs of his close encounter.
Actually, I feel pretty good. Every muscle in my body is really sore. I have a slight headache, but other than that, I feel great. I feel very lucky.
He went back to the gas station today to finish filling up.
But I mean, that's pretty remarkable to see him here today. And I'm glad he's here with us to tell the story too.
Now that we've covered lightning, I think we should cover thunder really quickly. The electrical discharge of lightning generates incredible energy in the form of electricity, light, and heat. A typical lightning strike is about 28,000 degrees Celsius. This incredible heat causes the air around the lightning bolt to expand rapidly, creating a vacuum in its path. As soon as the heat from the lightning is removed, the expanded air collapses back on itself, creating a huge booming noise we call thunder. In other words, this lightning strike right here will cause the air, maybe the air right between these two arrows here, to expand so much that as soon as that heat is removed, it's basically like there's a vacuum here. And the air from this side will rush in, and the air from this side will rush in, and as these two arrows, as these two little bits of air slam together, that's where we get our booming noise. And the lightning waves, the light from the lightning moves away very, very quickly, the speed of light, and that's almost instantaneous that you'll see the lightning. But thunder is much slower, moving at only the speed of sound. So as soon as this happens, that sound wave will slowly move away, even though the lightning got to you almost instantaneously. Now to finish up, there are two types of thunderstorms I'm going to want you to know. There are air mass thunderstorms first. Air mass thunderstorms are small isolated storms located in the middle of an MT, or a maritime tropical air mass. They typically last for about 1 hour before breaking up. In your notes. So MT air masses have small isolated storms that last for about 1 hour. And here's a closer view of what exactly is happening. At first you just have an air mass. It starts rising, and because that air is so unstable, because that air has so much heat and moisture in it, it's going to keep rising. That's going to kind of feed more and more air to it. So as it's pulling more and more air up into it, more air is able to move up, cool off, and condense into the storm. And then this storm is going to dump a lot of that rain, that condensed, back down. This is the mature stage, as it may produce tornadoes, may produce heavy rains, brief period of time. And then the dissipating stage, it's still raining, but this is a heavy rain at worst. Great, and getting these in our notes would be nice to be able to remember that. Last thing, frontal thunderstorms. Now, last lesson we learned how a cold front will be able to push up lots and lots of warm, moist air and cause thunderstorms. Well, this picture is showing how that kind of takes place. So we have a cold front pushing through, and as it pushes through, we have a long line of storms. So, frontal storms develop in the warm air directly ahead of a cold front. They develop in a large line called a squall, stretching over much of the length of the front itself. Because they are all together, frontal thunderstorms are much more severe and long-lasting. Frontal thunderstorms can go for hundreds and hundreds of miles and cover many states. So a frontal thunderstorm is at the edge of a cold front and can be very wide and last a very long time. And so we have a cold front pushing in here, pushing up that warm, moist air, and if you look at how wide this is going all the way from Illinois up past Maine into Canada, and the strongest thunderstorms can cover the entire eastern seaboard. So now the last thing you're going to need to do is try to fit these two diagrams in your notes. It's important to have more than just the words here. You're going to want a diagram to help you remember it.